Hi and welcome to the Foundations course lesson 7 on Modeling Basics Part B, Linear Regression. We are going to look at the most important characteristics of linear regression models again because it forms the basis for understanding the other types of regression models. So you probably recognize this table summarizing the most important aspects of the different types of regression models. And in linear regression model, we are modeling to predict a continuous outcome measure. And we don't have to use any link function because it forms the basis itself for the other types of regression models. And the mathematical function that we're using is y is beta 0 plus beta 1 times x1 plus beta 2 times x2 and so forth for additional variables in the model plus e, the residual term. The effect of variables in the model is additive and is expressed by a difference in mean relative to the baseline value. And if we want to test for significance of single parameters in the model, we use a t-test, but if we want to test for the significance or performance of the entire model, we can use an analysis of variance based on the F-statistic or a likelihood ratio test based on the chi-square statistic. And we can also look at the Kaike's information criterion. And the model fit and performance is usually summarized in the R-squared, which is defined by the percentage variability in the outcome explained by the model. This is a standard output for a statistical software package showing the summary of a linear regression model, in this case a simple linear regression model with just one variable, a categorical variable x1. The equation is beta 0 plus beta 1 times x1, and as the first parameter in the output we get beta 0, which is a constant, and the meaning of this beta 0 here is the baseline value or the intercept of the model. To put it differently, it's the value of y if x1 is 0. And the output will give us a standard error for the regression coefficient beta 0 and a t-test statistic, which is nothing else than beta 0 divided by its standard error. And we get a p-value based on the t-test, where the null hypothesis is that the regression coefficient beta 0 is 0. So under that assumption, we calculate the probability of observing a regression coefficient at least as extreme as beta 0. And the second parameter in the output is the categorical variable 1, x1, with estimate beta 1 as its regression coefficient, a standard error, the t-value for this regression coefficient as well as the p-value. And the meaning of the categorical variable x1 is that it increases the baseline value with the value of beta 1 for those individuals where the categorical variable 1 is true, or in other words has the value 1. Now if we add other variables, we get a multiple linear regression model. And this is how the output could look like, where we have two additional variables, x2 and x3, which are both continuous variables. And the same principles apply here as in the former model. Beta 0 gives us the baseline value of the continuous outcome y for the situation where x1, x2, and x3 are 0, and categorical variable 1 increases the baseline value with the estimate value of the regression coefficient beta 1 if that categorical variable is true. Alright, so that's it for the basics on linear regression modeling. And our next stop will be logistic regression.